Hello guys, welcome back, and today we will discuss this problem on univariate continuous distributions. It's the problem goes as follows: that it's a really pretty interesting problem because it involves functions of random variables. So let's see how it evolves and blooms. So it's a past year problem from ISI MStat 2019, problem number 20 PSA. So it asks that if x is distributed uniformly on -1, 1, and we calculate this corresponding probability pi, which is the probability that x square, okay, belongs to this I by 4 comma I plus 1 by 4, this interval. So this, for each of this pi, the each of this I, it will be a different interval and hence a different pi. So the question demands that for which I the pi will be largest. Okay. So this problem may pretty seem straightforward, and but we'll check how we can do this straightforward problem. And so essentially the goal is to convert back the problem into two halves. Okay. Into, like, in terms of x rather than x squared, because we know the distribution of x. So let's see how we can do that. So um, so therefore, we have this corresponding probability. We are asking for this corresponding probability that, so pi is equal to probability x square belongs to I by 4 comma I plus 1 by 4, right? So you can write this as same as probability that x square is less than or equal to I plus 1 by 4 and greater than equal to I by 4. It does not matter less than or equal to, because um, it's a continuous random variable. So the endpoint probability is always 0. So it does not really matter. So using this, we can actually convert this into the knowledge of, into x rather than x square. So therefore, you can write this, since remember that x belongs to -1 comma 1. Okay. So x, the range is x is, so rather than not saying belongs, it's x less than equal to 1 and greater than equal to -1. So therefore, we will accordingly plot the whole thing and find the whole thing. So if you try to understand, and let's try to draw the graph of y x square. So it's asking that what is the probability. Let's call it a and b. So it's essentially asking what is the probability that x is lying between a and b. So this is a and this is b. So the probability, can see that it's nothing but, it boils down to this, that it's x is lying between these two values or these two values, and they're symmetric to each other. Okay. So if you ask that probability x squared is less than equal to a and b, it's same as it's telling that probability x is less than equal to root b and root a, plus probability x is less than equal to minus root a greater than equal to minus root b. Yeah, that's what this is root a, this is root b, and this will be minus root a and minus root b. Yes, so that's the idea. So this is point a, this is point b. So this is the basic idea. So therefore we get that this is same as, so now probability, since it's this length is nothing but what this length is, so therefore it's nothing but, since x is um a uniform distribution, it's nothing but it's nothing but this length, right, by the total length plus this length is also same, right, root b minus root a by 2. So essentially, so it should not be if and only if it should be equal to. So therefore we get that this is equal to this is equal to this, which is nothing but root over p minus root a, because there are two aspects and both the lengths are same. Okay. And hence they're adding up. And why by 2? Because x is taking values from -1 to 1. So fx, the PDF is nothing but 1 by 2 if x is between -1 to 1 and 0 otherwise. So therefore, you can see the length will be like, the probability in this region will be length by total length. That is 1 minus 1 is equal to 2, right? 1 minus of minus 1. So total length is 2. So therefore it's relative length. So it's essentially b minus root a. So therefore we get that this is nothing but it's essentially equivalent to root over I plus 1 by 2 minus root over I by 2. So it's asking that for which value of I this is the highest probability. So you can take half common, so we get this beautiful third which we have dealt in our school days, this. So therefore we get that's nothing but half times, we just do how such we rationalize it, so we divide it by this, right? So upper may we get just 1. So therefore we get 1 by twice of this root I plus. So now your question is that what really helps? Like, why this useful? It's useful because you can understand this is a function in I, right? Pi is a function in I. Pi is a function in I, okay? And you can see that this is as a I increases, this decreases because this is increasing and therefore it's 1 by that. So therefore Pi decreases. So therefore the maximum will happen when I is equal to 1 and the minimum will happen when I is equal to 0 because it's decreasing. I is equal to 4, okay? Because the question asks that it's so it will be 0 and 1 rather I should say, so 0 and 3. So it will the when I is the smallest then pi is the maximum, and therefore we get for I is equal to 0 the value that we get is that p0 is turning out to be yeah, so p0 turning out to be half, I guess. Yes, half. So that's pretty big, right? And for I is equal to 1, it's turning out to be, you can see root 2 minus, yeah. So nothing really interesting. So less than half, for sure. So therefore, this is a pretty beautiful idea over here that what we have got. Let me just check once. So for I is equal to 1, we get pi to be root 2 by root 2 minus 1 by 2, right? So which is pretty less because it's 0.414, so by 2 which is 0.2 something. So of course, yeah, for 0 I is equal to 0 its maximum is coming, and therefore we get the question that for which value of I it's a maximum, for I is equal to 0 it's a maximum. So you can think about a food for thought question can be, people love food for thought questions because they can create new questions out there. Can be what happens if x is it's not x square but it's x to the power n, okay, belongs to a comma b. How will you do that? How will you do that and solve that problem? So it depends upon whether n is equal to all or not. So that's the question for you. So that's like the food for thought question for you, that how will you find probability x to the power n belongs to a comma b. Okay, a comma b is fixed, so you can know that, or we will the same thing, I by 4 to I plus 1 by 4. For which value of I this is a maximum, given n is fixed. So you try to do this problem. Given n is fixed, for which value of I it is a maximum. So that's the question I can have as a food for thought question. And you can extend this problem. You can extend this problem to an in general polynomial or function. But yeah, x to the power n sounds a pretty good extension of food for thought question. So do share your answers in the comments, and you can upload a video to the a link or a video or whatever explanation Google Drive and share it in the comments. We will love to check and comment on your solution. The right solution will be commented down in the description below. Thank you guys. Thank you for staying tuned and listen to the end of this, and listen to the food for thought questions, just not listen to the answer. So I hope this encourages your to do more problems, and it enhances your intellectual capabilities for the examination and learning purposes. Thank you guys. Stay tuned and stay blessed, and have a very good day. All the best. I will see you in the next video. Stay tuned and stay blessed. Bye bye.